Here we are again. Yesterday I had some technology problems and I noticed halfway through, or when I was done videoing, I looked back and the internet stopped on me. And so if you were gone yesterday and watched my video, you got to about question B or C. Well, no fret, because we got to about B or C yesterday in class, and the guys at school were doing really, really well on all the work leading up to this. And so today we're just going to take a quiz. So make sure you take the quiz when you get back. And then we're going to finish this video today. We were still able to do the homework last night, practice page, even though we didn't get all the way through the second page here of thinking about all these equations and graphs and interpreting all these questions on the lesson 8, the third page here, these questions of A through F, I think it is. So we're going to continue here about this. I think this is about where we left off yesterday. We're talking about some key words here in our directions here that said something to the fact of what happens to the y values of the function as the x values increase. So these are the two key words here. So what happens to the y values as the x's increase to a very large number? So there's the first question. So let's look at graph A. And I want to have you pause the video and then tell me what you think, because it is kind of a thinking question. Write your answer and then come on back and we'll see how you did. Give me what happens when the y values, or the x's are increases, what happens to the y values. Okay, so here's my thinking. As I'm going along here, is my y value or x values are increasing, so I'm looking at 2, 3, 4, 5 and heading this way. For the most part, my graph, my y values are going up. So I'm going to say as x's increase, can't say all of them, because over here my x's would be increasing here, but I see my y values are decreasing. As the x's increase, most of the y values are increasing. And I want to say to positive infinity, because that graph goes forever in that direction. Okay, so let's go over to graph B. So now here, I'm just going to start at 0, and as my x's are increasing, my y values are decreasing. To negative infinity. Okay, let's go to the second part. What about as the x values decrease to a very small number in the negative direction? So if I start looking this way, my x's, as I'm going this way, they're decreasing. -2 is smaller than -1, and -3 is smaller than -2. So as I'm decreasing going this way, my graph is also increasing. Because my x's are decreasing, it's the same thing as up there. My y values are increasing to positive infinity. Should I add the word 2 in there? B. Again, here's my x values. As my x values are getting smaller, I have the same thing. My y values are getting smaller and smaller too. And they decrease to negative infinity as well. All right. All right. How can we know whether a graph of a quadratic function opens upwards or downwards? Well, if you're looking at a graph, the most basic thing, you just look at it and you can tell whether it opens upwards or downwards. I think what they're getting at here is that they're looking at the actual function, like written in f of x form, and we say minus 3x squared plus 2x minus 4. How would we know? And so what they're looking for here, I believe, is if the a is positive, what did we learn on Monday? The graph opens upwards. If the a is negative, the graph opens downward. I think that's what they're looking for on that one. Okay. Is it possible to determine the exact intervals that a quadratic function is increasing or decreasing by just by looking at a graph of the function? It's kind of interesting. As I was reading this one, it says look at row 6 in the chart. So 1, 2, 3, 4, 5, 6 is right here. 1, 2, 3, 4, 5, 6 is right there. Identifying the intervals on which functions are increasing and decreasing. Is it possible to determine the exact intervals that a quadratic function, so the exact intervals would mean like kind of the slope. So if I'm going from one to the next, an interval is increasing or decreasing by just looking at the graph of the function? I would say if we're looking at the actual graph, like it says here, we can tell an exact interval because we would just do 2 points here. But if I'm just looking at row 6, I would say not, because we don't know if this graph is going up or down. We just have a coordinate called 4, 3. And I don't know, if that's all I have. When we say look at row 6, if that's all I'm looking at is row 6, I don't know that I would know where my vertex is, because my graph could go this way and my vertex be up here somewhere. But it could go like this graph is and showing that way. So, I guess I would write here, because this is one of those questions I'm not really sure. I would probably say if I have the vertex, yes. I would know which way the graph is opening. Well, it's kind of an interesting question, because I'm not sure. But again, sometimes Eureka Math, they just want you to kind of think about things in that way that, again, they kept telling us when they were training us, sometimes there is just no right answer, that they just want us to think about, if I just have this row here, would I be able to tell? Some kids would interpret it just like I did. Well, yeah, they have the graph here. So if I have the graph, I can tell the intervals here, because I can go, like we were talking about, I can go from here to here and I can tell what my rate of change is. And I can tell whether it's increasing or decreasing. So, yeah, you could write that as well. So you could say, yes, I could see on my graph that I went from this dot to this one and I'm increasing. Okay. All right. So sometimes when they say, as long as you write something, it's the right answer. Explain why the average rate of change over the interval 1, 3, so we went from 1 down to 3, was, for graph A was 0. Well, let's look at these coordinates over here. Coordinates 1, 0 is right here. And then also 3, 0 is right there. And so it's a horizontal line, isn't it? And so the slope of a horizontal line is 0. But we also did the math over here that we said 1 and we went up to 3. So my x in the denominator was a 2 and my numerator was a 0. So that also equals 0. So I would say on graph A, by using the graph, I'd say the line is horizontal. Therefore, rate of change, because that's what they're asking, is 0. Because we didn't change. We went from here to here and we didn't go up or down. Let's see what happens over here. Where's my 1, 3 here? 1. Oh, they just asked me for graph A. Okay, so we answered it. All right, so we didn't have to do letter B. All right, let's move on to G. How are finding the slopes of a line and finding the average rate of change of an interval similar? How are they different? All right, so pause the video and think about that. Write some kind of a response and then come on back and let's see what my thinking is. Okay, here's my thinking. And again, I want to try my line tool, which I thought I figured this out at one point. If I'm going to go from this dot down here, my internet's going to be a problem today again, I can tell. Okay, so where is my line tool again? Let's try this again. If I was going to go from my rate of change from this dot down the best I could to this one, and it was a linear line, it would look like that. Okay, and then if I had another dot, so I'm going to do another line. If I said I wanted to know my rate of change from this dot maybe to this one, see if I can move that real quick without. Do I have an arrow somewhere? Dang it. That's not a very good line. Sorry. Bear with me here. Do this. There's got to be a way to move that line. I'll figure it out sooner or later. Let's pretend I'm going there to there. That's pretty close now. But look at, now these are linear lines, obviously, my green ones. And you see how my slopes are changing? This one has a very steep slope, even though I'm going from this point to this one, and then from here to here, I have a less steep slope. And so when I do a linear line, my slopes are always the same as far as my rise and run. I could go from here down to here, and it's going to be over 1, down 2. I could go over 1, down 2. That's a little bit more than 2 because I didn't really pick a good coordinate. Okay, but my point is that our slopes on a linear line are going to be the same. Whereas on a quadratic, because we have a curve here, my slopes are going to be constantly changing. No matter where I go on my rate of change, all of our numbers are going to be different, okay, getting up there. So how are we going to write that? Let's think about it. So they said, how are they similar? Well, I think, in my opinion, that one's an easy one. That they both have the change in y's over the change in my x's. That's the symbol for change. So, Oops. How are they different? If I did a line that was just a straight line, all this on a line, the slopes will be the same. Put on a quadratic, my slopes are constantly different. As I go from point to point, I guess is the best thing I could do to describe it. So again, if I go from this point to this one, that's going to have a slope, but it's going to be different than if I go from that one to that one, or that one to that one, versus on a linear line. If I just had a line, my slopes are going to be the same all the way up that line. Okay, that's what I was trying to verbalize there. Take some practice. All right, let's go to H. Can you graph a quadratic function if you don't know the vertex? Can you graph a quadratic function if you only know the x-intercepts? So there's two questions here. Can I graph if I don't know the vertex? I'm thinking I can't because I don't know if the graph goes up or down. I don't know, if they just say, give me a coordinate here, and I have no idea where I'm aiming for, where my vertex is. I don't know if my vertex is up here, so I don't know if my line's going to go this way, or if it's going to go down this way. Okay, can you graph a quadratic function if you just know the x-intercepts? I think the same thing. That is, I'm going to get rid of all this. If I just know the x-intercepts, so that would be these guys down here, I still don't know if my vertex is up or down and which way this line should go. All I have is two dots. So I'm going to say the same if I only know the x-intercepts. Remember that we need to know at least 2 points to define a unique line. Can you identify? So what they're saying is if I have 2 points, I know that's going to be a nice straight line. Can you identify a quadratic with just 2 points? Well, I don't think we can because we just showed that right here when I just said that here's my 2 points. I need, again, it's very much like the question up above. I'm just going to speed things up here. As long as I write clearly. As above. Okay, same answer as above. If I only have 2 coordinates, even if I had the 2 coordinates going this way, I know it's going this way, but I don't know how high it goes, or maybe, well, I do know the direction it's going this way, but I don't know how high it goes. It could go way up here and then back down. So I don't know the vertex. So I don't think so, would be my answer. What's the minimum number of points you need to identify a unique quadratic function? Explain why. Well, put what you think, and then we'll discuss it. Okay, I would think you need at least 3 points. But the problem with if you only have 3 points, it would look like this, and I still don't know where my vertex is. I would say 3 points if one is a vertex, because then I could say, okay, I have a point here, I have a point there, and I have a point there. I could kind of get a good quadratic, but I want to say, but you really need what we talked about on Tuesday, 5 points with 1 being the vertex. If I had 5 points just like this, and that's just the way my numbers ended up, I still don't know where my vertex is. But if I had 5 points and one of them is my vertex, so there's 3, and then down here I'd get another 4, and then I can draw a pretty darn good parabola. Okay? And also Fisher's rule is, in most teachers, you have to have 2 dots somehow out here near the edge. So you have to manipulate your X's here until you get 2. One girl did a really good job the other day on the graph, because our homework, the graph was, let me clean some things up here real quick. The points that they gave us on Tuesday's homework had something like this, dots like right here and right here. And so she did a good job of changing the number and made another one that was up here, so that she did what I said. You have to have 2 dots near the exit of the graph. And so she manipulated those numbers to make that happen. So that was really, really good of her. All right. Here is our homework now that you should have done. All right. And on this homework, I'm hoping that you notice that this is my vertex, and then over here, that's 2 away. This is going to be my axis of symmetry, so I want to just draw that down there. It's a good thing to do. And I'm hoping that you did this, and then 1, 2, 3, 1, 2, 3 over here, and you continue your graph like this. Now I'm going to give you a little heads up because I was helping some kids after school. When you do your X values, my lowest number on my X chart here is a -3. And then I have a -2. So it helps on the last question if you put these guys in order. Somebody kind of did it this way. They said, okay, I have a -1, I have a -2, and then they have a -3, and they did their coordinates this way. And so it kind of messed up that last question that they were trying to solve there. All right, so there's my graph. And so all you had to do is fill in the table here. At -3, it was a -6, I believe. -2 was -1. And then it was a 2. 0, 3 was my vertex. I like to put a box around my vertex when I do that. And then we had a 1, 2. And then we had a 2 -1. And then a 3 -6. So that table would help if you had it in that order. Up there, what are the coordinates of the x-intercept? Right there they are. What's the coordinates of the y-intercept? Again, nice easy one. I hope you said 3. What's the coordinates of, and when they're saying coordinates, you have to write it as a coordinates. So the coordinates of the y-intercept would be 0, 3, I believe, up there. What are my x-intercepts? I had 2 of them. And then they asked what the coordinates are, so they want it written as a coordinates. Now on this one, please don't say 2, because -2 is down here. So you're going to have some kind of a decimal here. So, and usually you do this, the lowest one first. So I'm going to go to the left. The -1's right there. So I would say maybe -2 0.75. And then I wouldn't go up or down. And my second one would be, well, if that one's 0.75 on the negative side and they're intercepts, then this side has to be a positive 0.75 because it's on the positive side. That's kind of probably what they were trying to strive with on that one, that these two numbers here have to be the same because my axis of symmetry on this graph goes right down the middle. So if that's our point, and I just noticed I need a 1 in there, don't I? It's negative. Or I erase this whole thing. Caught my mistake. So it's a negative 1.750. And on the other side, it should be a positive 1.75, 0. Now you had something in that range. You might have said 1.8. Somebody said negative 1.7 on the last night's homework when they were after school. So that would be okay too. What's the coordinates of the vertex? I thought we did that one. Oh, we did. Is it a maximum or minimum? If we knew the equation for the curve, what sign would be the leading coefficient? So they didn't give us the equation. So that gets back to what would my leading coefficient be if my graph is going this way. All right, and the last one, this is the one that some kids had a little bit of a problem with, these last two. They said, here's my interval, change in interval was from negative 3 to negative 2. So I went from negative 3 down to negative 2. So that means I'm going to go from negative 6 down to negative 1. Negative 3 down to negative 2, or up to, is a plus 1. So that's going to be my denominator on that one. And then I want to go back to my graph, and I had a negative 6 up to a negative 1, which would be up 5. And they said show it as 5, show your steps. So I would just recommend that you copy these things. It was negative 3, 6. On my table here, I just copy that part over. It was negative 3, 6. Whoops, I don't want that line in the middle there. Or do I? Yeah, it was a table. This was my x's and this was my y's. And then my other one was negative 2, negative 1. And so then I would show that I went from here to here, just like I did on the board over there, and that was plus 1. And I went from here to here, and that's a plus 5. And I would show my work. I went that there, and that equals 5. So you might try that on this one down here, based on your answers in row 6. So this is the problem. If you didn't put them in order, things are going to be a little bit crazy on this one. So challenge 2, what interval would have the average rate of change of negative 5? Explain. So I hope you tried it. So let's go up and look. I'm sure kids are going to ask today on the homework. So if I look at row 6, 1, 2, 3, 4, 5, 6. I'm looking at this row here. That's the one I'm looking at. And they want to know, I want an average rate of change of a negative 5. So that means I need my final answer to be a negative 5 after I'm doing my y's on the top and my x's on the bottom. So if I go from here to here, I went down 1, and then I went from negative 2 to negative 2 to 1. So I went down 1. So then I'm going to go this way on this one as well. I went from negative 1 to 2. So I went up 3. So my fraction would be a 3 over negative 1. Well, that's not giving me a negative 5. So if I went from If I went from 2 to 0, well, that means I'm going down by 2. So that means I would go from here to here. So I went from negative 1 to 3. So that means I went up by 4. So that would be a 4 over negative 2, which equals negative 2. And you're probably yelling at me right now. Be patient. I did that one on purpose. So if you went the other direction and we went this way, I went from 2 to 3, so that's a plus 1. And I went from negative 1 down to negative 6, would be a negative 5. And so that would be a negative 5, over 1. And so that would give me this over here. So what I would do is copy this whole part down to that question, because they say explain. So 2, negative 1, I think was our first one. And what was my other coordinate? 3, negative 6. So then I would again show my work like this way. I went from here to here. My y's are on top, my x's are on the bottom. And I would say change. Change in my y's was a minus 5, and my changes in my x's was a plus 1. There you go. And that's kind of explained mathematically. Okay? All right. Well, we're going to take the quiz. There's no homework unless they don't finish this paper today, which I'm sure they will. But there's no homework for the weekend, and we'll pick up on Monday. We're going to get more into graphing by axis of symmetry, finding the vertex, so lots of computation. All right. Have a good day. I hear the vacuum guy coming. Have a good weekend.